How about now?
Yeah. Yeah.
Okay, it's good.
You know, oh, then one other thing. Okay, cool. All right. So if we use like K to represent the layer, so the first layer of boxes I think has 4 boxes. The second layer has, what is it, 8 boxes? Is that correct, guys?
Yeah.
All right.
8. And the
And,
third has 12.
and the third has 12. And then what does it want to know? Like, does it want to know the total number of boxes in 12 layers?
Good number of boxes.
So what is the total? Number of boxes in 12 layers. All right, so look, hang on one second. Thing. Okay. All right, so here's going to be our general strategy. We're going to write the arithmetic sequence. So first find, we'll call u with the subscript n. This is going to be the total number of boxes in each layer. So remember our formula for that? It was like un equals u1, in this case, the number of boxes in the first layer, plus n minus 1 times d, which is the common difference between the terms. So this tells us the number of boxes in each layer. And then we're going to use this next formula. And I don't think I gave this to you guys last class. We're going to use another formula, which we'll call Sn, which can also be written as the sum of, in this case, from k equals 1 and all the way up to 12. Actually, I should leave that as a, let me just leave that as an n for now. Call it, this is an n. So in this case, we're going to go from k equals 1 to n, and we'll have a formula for this. We'll call it like un. And this is going to equal the total number of boxes in this case divided by 2 times u1. We'll talk about this maybe in class, like where does this formula come from, plus n minus 1 times d. So if you look, this formula basically comes from the number of boxes per layer. Okay, so I'm going to show you how to use this formula today. The first thing I'd like to do is let's figure out what is the common difference, right? So how do you go from 4 boxes to 8 boxes? What's the common difference between those two?
4.
You add 4.
4, good. And from 8 to 12, what do you have? What's the common
You
difference?
add 4 as well.
Add 4. So this is an arithmetic sequence, okay? And so the first thing we want to do is let's write un, which is in this case the number of boxes per layer. So if we want to know how many boxes are in every layer, we just use this formula. What is u1 in this case? What is u1 equal to?
4.
4, very good. And so then I'm going to just do plus 4 and minus 1. And then d we said was 4.
4.
Right. So let's do this. Let's find out how many boxes are in the 12th layer. So can you guys find u12, the number of boxes in the 12th layer? Did you guys do that for me? Number of boxes.
$48.
So 48. So you did 4 plus 12 minus 1 times 4. So this would be what, 44 plus 4 would be 48. So in the 12th layer, there will be 48 boxes, okay? So now if we want to figure out the total number of boxes, we're going to use this equation. So Sn, all right? And in this case, this is going to be the total number of boxes divided by 2 times u1, I'm sorry, 2 times u1 plus n minus 1 times d. So in this case, we have 12 rows or 12 boxes, layers of boxes, times 2 times u1 is 4 plus 12 minus 1 times d. Oops, sorry, not just d. We want to do times 4. We know all the numbers. So what I often do before I plug numbers into a calculator is I just try to simplify these. So like I know 12 divided by 2 is 6. 2 times 4 is 8. Plus 12 minus 1 is 11. 11 times 4 is 44. So like I just do this before I like plug numbers into a calculator. So what do you guys get when you find this number?
324.
324. So there are 324 boxes in this store display. So there are 324 boxes in the display. Okay. Does this problem make sense so far? All right.
Yeah.
Let's take a look at this problem right here. So this is the next slide. So this is the problem we just did was slide 8. Let's take a look at this slide right here, slide number 8. It says find the sum of the first 60 terms of the series. Okay, and then it has 5 plus 8 plus 11. Okay, so I'm going to do this one. Let me just make sure. Yeah, I'll do this first one with you. Okay, so this one, we'll kind of walk through it one more time.
Okay.
Let me just delete this. Get started. So this one is 8, 11. So can you guys see my screen? 8, 11. What was it? What was the next term? 5. Oh, sorry, I wrote this wrong. Was it 5, 8, 11?
5, 8, 11.
All right, so what's the common difference between these terms? What's the difference between 5 and 8? What do you have to add?
3.
3, and 8 to 11 is
3.
3, very good. So our common difference is just 3, okay? So we can now notice that this question says, so this one just says find the sum, okay? So we're just going to look for the sum. So for this one, when it says find the sum or look for the sum, we're just going to use this formula, Sn. So this just means the sum of the terms in the sequence. And we're just going to do the formula n divided by 2 times 2 times u1 plus n minus 1 times d. Okay, so this just gives us the sum of a finite series. So this is the sum. All right, the sum of a finite series. So to figure out our answer, to find our answer, what's the total number of terms in this series? Do you guys remember?
60.
So 60. So I'm going to do 60 divided by 2. And what is the first term in this sequence or series? It's the first
5.
number. Very good, 5. And then we're going to do plus, n is going to be 60, so it's going to be 60 minus 1 times 3 in this case.
3.
So what does it work out to be?
3.
What's 59 times
7.
3? What's just this part, 59 times 3?
59 times 3 is 177, I think.
Does everyone agree 177?
Yeah, 177.
So notice like the easiest way to avoid a mistake using your calculator, just do these parts out so that you can get something simpler. And then you can just do like 30 times 10 plus 177 should be 187. It's easier to multiply two numbers and get the correct product as out of your calculator. So what do you get when you do this?
5,610, I think.
5,000, say it again.
110.
Matai, say it again.
610.
600.
10.
10. Does everyone agree? Anyone disagree? All right. Before we do that next one, I just want to check one thing here. Yeah. Okay. Before we do the next one, before we even look at the next one, can you guys tell me what is U60? So like, what is U60? The 60th term. Can you guys find that for me? You're just going to use this formula U1 plus N minus 1 times D. What do you get when you do that?
$182.
182. Does everyone agree?
Yeah.
All right. So guys, I want to show you, before we go on, I want to show you why this equation works, all right? So for a moment, you don't have to write anything down, okay? So all I want you to do is kind of pay attention and watch what I'm going to do. Do you remember when I told you like Carl Friedrich Gauss said his teacher said, I want you to add up all the numbers between 1 and 100, and immediately Carl Friedrich Gauss saw oh, what do you do? So instead of trying to show you how to do it with 100 numbers, let's just look at adding up all the numbers between 1 and 10. All right. So what Gauss immediately saw was, okay, if I write all these numbers like this, and then I write them in descending order right below it, and then what he said was, well, what if I just add up the numbers vertically? So what is 1 plus 10, guys? What is 1 plus 10?
11.
11. What is 2 plus 9?
11.
11. What is 3 plus 8?
11.
11. So you got to get the pattern. So then we just get 11 over here and 11 over here. Now, how many of these 11s are there? What's the total number of 11s in this case?
10?
Yeah, 10, because there's this was first, second, third, 9, and 10. So there are 10 times 11 11s, okay? Now, how many times did I add these numbers together? How many times did I add 1 through 10 together? What did I do to get this? Yeah, I had to do it 2 times, right? So remember we said, well, this is not the sum of 1 through 10. We've counted the sum twice, so we have to divide it by half. And so in this case, we get 10 divided by 2 is 5, so there should be 55, okay? So let me give you some analogies. In this case, n is equal to the number 10. 11 is equal to the number n plus 1. And then right down here, we have to divide it by 2 because we're adding it together twice. So when I gave you this formula, so I gave you Sn equals this, I hate this formula, but I'm going to give it to you. I have to. It's written like this, n minus 1 times d. Notice you don't know what the common difference is from this formula, okay? But we've had to write this. We've had to write the arithmetic sequence just because it's something that you have to do as u1 plus u. Since we've been writing this formula like this, to find the sum of all of those terms, this is one of the equations that we can use. Another equation that we can use is, I'm just going to write this as the sum of, say, let's use k to 1, n of like k. We can also write this as n plus 1, sorry. It turns out that these are the exact same formulas. Okay, and sometimes this first formula, they don't really have names. Sometimes this formula is the easiest formula to use to find the sum of a finite number of terms. Sometimes this formula is the easier formula to use to find the sum of a finite number of terms, okay? So with that said, oh yeah, Jennifer, go ahead.
I have a question.
Yeah.
So you see, like, I didn't do this on purpose, but when I was doing this like ahead, I was looking up some formulas and I found this one formula that says S of n equals n over n divided by 2 times u1 plus un. Is
Yeah,
that
okay, yeah.
also
That's a good question. So let me show you where that comes from, okay? So what Jennifer is saying is she found another formula that looks like this. And let me know if I heard you correctly. Just like this, is that correct?
Yep.
So what I've done with this formula is I've taken this formula. So I'm just bringing that u1 down. And then this other term, this other un term was equal to u1 plus n minus 1 times d. So what I did in the formula that I gave you is I took this term and I added them together. So you can get n over 2, and u1 plus u1 should be 2 times u1. So you bring up a very good question. So what I did is I took this formula and I just simplified it, made it a little easier, or maybe I made it a little harder to see. Ali, go ahead.
Mr. Tim, Raj just sent me a message and he told me he couldn't get in the meeting.
Okay.
So could you please send him an invite?
Sure thing. Let me find him.
Like she sent me a picture and it says that waiting for the host to start the
Okay.
meeting.
Yeah, all right. Let me stop sharing the screen for 1 second.
He clicked on the wrong link. Like he clicked on the main link, I think.
Oh, can you
Instead of the one.
all right, guys, hold on. Check it out. Let me, if you guys could, while I try to find a way to let him in, could you guys go to this slide and try to find, so you're going to do 2 things. So first, show that the series is arithmetic. What that means is find the un equals u1 plus n minus 1 times d, and then do this one. All right, so there are 2 slides, all right, that are the same problem. So would you guys try to do that? And I'm going to try to find a way to let,
I think you can just send an invite by email.
Yep. Could you tell him to email me? Could you send him a message and tell him to email me?